So today I am going to explain linear regression, which is one of the simplest and most important supervised machine learning algorithm. So let's see what is linear regression. Linear regression is a supervised learning algorithm that learns from labeled data, as we seen in the previous one, where supervised learning is based upon labeling data. It tries to draw the best possible straight line through data points. The straight line represents the relationship between the input and output. Basically, as the input changes, the output changes in a predictable linear way. So let's see why linear regression is very much important. The first one is very simple and easy to understand, and second one is it helps predict future values using past data. It next it forms the base for many advanced models. It works efficiently when the data has a linear relationship. It is widely used in finance, healthcare, marketing, many real world applications. So let's see one example here. Let's say we want to have a graph between hours studied versus exam score. To understand this better, let's see an example. If we want to predict a student's score based on the number of hours studied, the input or independent variable is hours studied. The output or dependent variable is exam score. As hours studied increase, the exam score also increases, and linear regression helps us model this relationship. So there is a one line which is called as best fit line in linear regression. We try to draw a best fit line. This is a straight line that represents the data most accurately. This line minimizes the error between the actual values and the predicted values. Once we get this line, we can use it to make predictions for new data. So the goal of best fit line, you can see here, this is the best fit line where it is between inputs and outputs. The main goal of best fit line to reduce the error between predicted values and real values. So if we know the x value, the line helps us to predict the y value as accurately as possible. Let's see the equation for best fit line, which is y is equals to mx plus b, where m is the slope, b is the intercept, and x is the input, and y is the predicted value. The algorithm finds the best value of m and b so that the predictions are close to the real data. Let's see interpretation of slope and intercept, or we can say interpretation of best fit line. First one, the slope tells us how much the output changes when the input increases by 1 unit. For example, if slope is 5, then for every 1 unit increase in x, y increases by 5. The intercept is the value of y when x is 0. It tells us when where the line crosses the y-axis. Next, let's make an assumptions of linear regression. To make linear regression reliable, some assumptions must be met. The relationship must be linear, errors must be independent, errors should have constant variance, errors should be normally distributed, no multicollinearity in multiple regression, no repeating error patterns. So there are some limitations for linear regression. Uh, Linear regression assumes the data is linear. If the relationship is non-linear, the model won't perform well. It is also sensitive to outliers. Even one extreme value can affect the line. Let's see types of linear regression. The first one is simple linear regression. We have one independent variable predicting one dependent variable. The formula is y cap is equals to theta naught plus theta 1x, where y cap is the predict value, x is input, theta naught is the intercept and theta 1 is the slope. This is used when a single factor affects the output. For example, salary prediction based on the years experienced. Next one is multiple linear regression. In multiple linear regression, we use multiple input variables to predict one output. The equation is y cap is equals to theta naught plus theta 1 x1 plus theta 2 x2 plus and so on theta n xn. This helps when many factors influence the output. So to have a small summary about the whole linear regression. Linear regression helps us model relationships between variables using a straight line. It is simple, powerful, and widely used for predicting prediction tasks. When the data is linear and assumptions are met, the model performs extremely well.